This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. One section of statistics and probability is counting. In this section, we'll explore how many ways objects can be arranged. For example, let's take a maths book, a chemistry book, and an English book and see how many ways these books can be arranged on a shelf. Firstly, we could have the maths book, then the chemistry, then the English book. Or we could have the maths book, the English book, or then the chemistry book. Alternatively, we could have chemistry, English, maths. If we keep going down the options, we will see that we can have 6 arrangements for these 3 books. This method of finding the number of arrangements is fine when we have a small number of items to be arranged. However, we need an alternative method when we have a larger number of items. Let's look at this problem again. We have 3 positions to arrange. For our first book on the shelf, we have 3 choices. We have a maths book, a chemistry book, or an English book. So we have 3 choices for the first spot. Now, we have put 1 book on the shelf, so we have 2 books remaining. This means we have 2 choices for the second spot on the shelf. We had 2 books and we put 1 book on the shelf, so now we have 1 spot and 1 book remaining. If we multiply this sequence, 3 by 2 by 1, we will get 6. This is 6 ways the objects can be arranged on the shelf. This is the same answer we got by going through each of the different arrangements. Building from this mathematical formula for how many ways objects can be arranged is n factorial, where n is the number of items. In our previous example of the 3 books, n was the number 3. If we had more books, for example 20 books, the number of arrangements of 20 books could be calculated by 20 factorial, which would be given by 20 multiplied by 19 multiplied by 18 and all the way down to multiplied by 1. There is a function on the calculator to do this. This method of calculating the number of ways objects can be arranged comes from the fundamental principle of counting. The fundamental principle of counting states if one event has m possible outcomes and a second event has n possible outcomes, then there are m multiplied by n possible outcomes for the events together. For example, if I am considering buying a new car and I only want to buy either a Mercedes, a BMW or a Honda, there are 3 possible cars I could buy, or 3 possible outcomes. For each of these cars, there are 4 colours I am considering. There is black, blue, silver and green. So there are 4 possible outcomes for colours. To calculate the number of possible outcomes for the events together, I multiply by 3 by 4 to get 12. So in this case, I could have a blue Honda, a silver Honda, a blue Mercedes, a silver Mercedes, and so on, listing all the different possible combinations. This gets slightly more tricky when not all possible second events can be applied to the first event. For example, let's have a look again at the cars and the colours. Looking at the diagram, we see now that we have a problem. There are no silver Honda cars. We cannot multiply 3 by 4 to find the number of possible outcomes. We could list the possible outcomes and count them. For example, Honda blue, Honda black, Honda green, BMW blue, Mercedes blue, and so on. Or we could apply the fundamental principle of counting in a different way. This time we will apply it twice and add the two results together. Let's look at the left-hand side of the diagram, the Honda side. We have one car and we have three colours. Now let's look at the right-hand side of the diagram, the BMW and Mercedes side. We have two cars and we have four colours. So we have applied the fundamental principle of counting twice, and we will add the results. Adding our results together, we get 11 possible outcomes. Please check the answer by listing all the possible outcomes.